So this word harmonic motion, okay, is used to model anything that is in between, that kind of rotates in between, rotates. It switches in between going from a maximum to a minimum, back to a maximum, back to a minimum. Okay, so sine and cos curves fit those properties perfectly. They model those types of behavior nice, and so they're called that. It's called harmonic motion, or sine, and you use sinusoidal curves, a cos or a sine curve, to model that. All right. So here's a really simple example. They're talking about a graph indicates the depth of water off a certain pier in Texas. Okay, so what that means is they're talking about the tide coming in and out, right? So if this is my pier, and I can see what's the maximum height on the pier that the water is going to get to according to this curve? 3, right? It's right there. You can see it. Okay, and then as time goes on, the tide's going to go out. Okay, so it goes out gradually, like a sine curve does or a cos curve, right? And it's going to bottom out at when? -3. So you can tell me how you get -3 meters sea level, but whatever. That's the idea, right? Okay, so at about -3, it bottoms out. And as time goes on, day after day after day, okay, the tide rotates in between those things. It doesn't change, right? It goes in between -3 and +3, -3 and +3, like perpetually, right? Okay. So what we want to do, if we're gonna, they've asked some questions here. Okay, so what time and date is first high tide? Okay, so they're talking about this point right here. What time is it right there?
Noon, March 19th.
Noon. Noon, March 19th. Okay, when's the second high tide?
2:00 a.m. March 20.
Right, because this would be midnight here, right? Okay, so from noon to midnight, and then we've got 2 more hours, so this is going to be 2 a.m. Okay, and that's going to be the next day, right? March 20th. Get the idea? Okay. So if I've got, what's the distance? What's the amount of time in between here and here?
1 day and 2 hours.
Okay, or 14 hours, right? Okay, so that kind of sounds like the period to me.
1 morning and 2 hours.
Okay, so when's the first low tide?
7 p.m. March 19th.
That's going to be at 7 right here, right? Okay, so that's the first low tide, 7 p.m. Okay, so we've kind of got all the things that we need to make a cos or a sine curve here, don't we? We've got the period, we've got the amplitude, okay? There's no shift to this if we do a cos curve, but we have enough information that if we wanted to make a sine curve, we probably could, okay? So, how long is it? We did this already. So this is 14 hours, we said, okay? So if we wrote an equation in terms of sine, okay? I could start either here, or I could start here, right? Okay, so if this is 7, halfway, what's this got to be right here? 3.5, right? So my anchor point would go there. Okay, so write the equation in terms of sine. We've got all the pieces we need, like we said. Our amplitude's going to be 3. Our period is 14, okay? Meaning that my b is going to be 2 pi times 1 over 14, which is going to give me pi over 7, right? 2 pi over 14 is pi over 7, okay? And my vertical shift and my horizontal shift are both nuns. They must be Catholic. It's a poor joke. All right, so let's write the equation. So f of x.
Why is there no sign horizontal?
Oh yeah, I guess for the horizontal shift for the sine there would be one, right? Okay, so I'd put what?
-3.5.
Yeah, well, plus 3.5 is the horizontal shift, right? And then when we put it in the equation, we put it minus. You're right. Okay, so let's put it in. My amplitude is 3. Okay, and I have a plus or a minus sine curve here. Minus. So we got to put a minus out in front. Sine of my period was 14, so my b is pi over 7. And then x, x minus 3.5. Okay, and no vertical shift. Okay, so you just model out and away you go. And then write an equation in terms of cosine. I think the easiest one there is here, right? Okay, so everything's going to stay the same here, except for the curve and its orientation and the horizontal shift. So I'm going to go f of x here is equal to 3, positive 3 cos pi over 7 x. Okay, that's my equation. Right? And then now let's look at the calculator here a little bit. Do I want to do that on the video? Sure, why not? Okay. Grab your calculator. Okay. It's kind of important that we do the settings for these properly. All right. So let's set and consistently. All right. So let's set up everybody the same here. So let's open up a document. Here, I'm going to get rid of some of this stuff. Okay, and let's make a graph. Okay, the first thing I want you to do is let's go to the settings. So go menu, and then 9. Okay, and just make yours so it looks like mine. So you got fix 4, and that you've got radians. Okay. Every time like that we go to do one of these trig quizzes or tests, somebody always gets a weird looking graph, and it's because they're in degrees instead of radians. They don't have the right angle measure. All right, so let's go and make that your default. Okay, and just to test it, all right, to make sure we're in the right mode, go and push the trig button down here and put sine in. I think you guys know where all this stuff is. Okay, and just put sine x.
Where is that?
It's right beside number 7 is the trig graph, the trig button, and then you can you choose which one, right? Same as before. Nothing new here. Okay, but just so you see the right, graph, it should look like sine, right? If you're in degrees, here I'll just change it real quick so you can see. Okay, if you were in the wrong mode, it would look like this. You'd put sine x in and you'd get a line. All right, because it's trying to graph sine over 360 degrees, right? So up to 10 is like a really, really small angle. So you're only seeing the very beginning part of sine there. All right, so just like if your graph looks weird, make sure that you go check the settings, and that's probably what's going on. Okay, so let's go and put our graph in though, the one that we had for our function here. So it said, and let's put the cos one in because that's like they're both going to be the same, I suppose. But let's put 3 cos pi over 7x in. So I don't know if I can fit this on the same. There, that looks good. Okay, so tab 3 cos times pi over 7. Pi is down by h. Okay, you got to open up this little window to get it. 7. And here's kind of where you know if you made these equations right or not. Like we answered all of these questions so far without the calculator, and you should do it the same way. Like you shouldn't start, when you see one of these questions, you have to use a calculator. Don't just start pumping in numbers into your calculator, okay? Like you can draw this picture, or it's there for you already, and then you make the equation. And if your equation looks, oh, it went to degrees again. Oh, sorry. What did I do wrong here? Yeah, I didn't put x, right? I need an x. I need a variable. Okay? But if you see here, right, what you see here, you know it's right. Okay? So I want to go out a little bit further, but they were asking these questions. So what's the depth of the tide at midnight? Okay? So you just have to make sure that the x's, that you're translating your x's right. What number should I be putting in? Like what's the instruction to the calculator here? I want to find f of 12, right? Because it's 12 midnight. It's 12 away from 0. Okay? So on my calculator, go menu trace and dump the number 12 in, and it'll give you your decimal. Okay? So if you're on fix 4, okay, you're going to get the right answer out. So it's going to be, the height of the water is going to be 1.871. 1.871 what?
Meters.
Meters is right. Okay, yeah, because the question's in meters up here. Okay. And then I think if you flip, they ask you another one. It says find the first time that the tide is 1 meter. Like this is the same calculator stuff we've been doing the whole time, right? So you just find out, you put in another graph when it's a meter high, and it looks like this is the first time right there where it's going to be a meter high, right? Okay, so I'm going to go dump in an intersection. Do my little football post, lower bound, upper bound, and it looks like the first time that I'm going to get there is going to be 2.743. So 2.743 hours, right? Okay. The one thing I should do here is I should put in like what the equation is that I'm doing. Okay. So I just want to put 1 is equal to f of x. Okay. This, and then that's your answer. Those are your 2 points there. Okay.
Review the calculator again. I'll try something else.
So that should be good there.